Hello everyone, this is a fun opportunity for us to revisit the programming questions that a lot of us did very poorly on, and because I think one of the major reasons is that people fundamentally don't take the time to read and understand the question. If you're ever given something in a question, for in this case an array, don't then totally ignore it. The reason that you've been given an array is for a purpose. Don't rush it, don't try and think, oh I've got this, and then try and answer it straight away. Take the time to actually read the question. Maybe to help you slow down, it's worth bullet pointing it to maybe figure out what it is you need to do. Because if you rush it and then try and think you've got it and you haven't got it, then your solution won't be correct. Let's read this together. So, laser tag is a game where teams of players move around an arena shooting each other with infrared guns. Let's have some context. Players wear sensors that keep track of how many times they've been hit by the laser. So we know we have to keep track of it. What kind of data type would we be using to keeping track of how many times you've been hit? At the end of each match, players upload their score to a computer. The computer stores the scores in the order they're received in a 2D array called player. So this is the array that some people ignored completely, but is very relevant to want to answer our question. You see, this is our 2D array. What makes it 2D? 2D short for two-dimensional. A 1D array, a one-dimensional array would just be or like going across here or going here, that's one-dimensional. A two-dimensional array looks like a table. It looks like it here. And it's called player. The array stores the team as an integer, 1 for green, 2 for red. So we can see in the first game, what was the score that the green team had, Zahim?
45.
And the red team? Who won?
Green team.
Right? And we can use this then to keep a record of what's going on. And you've been tasked to use this. An extract of the player is shown, so this is only a part of it. The first entry is shown as a green team scoring 45, and the next team shows the red team scoring 30. Once all the players have uploaded their scores, so this is actually each individual player's scores, so this is an individual green team, an individual red team member, etc. Anyway, the computer adds up the scores for each team. Using Pseudocode, write a program for a procedural language that works out and outputs the total score for each team. So it's actually going to be how long in the real thing, the two-dimensional array? How long?
19.
How long will it be? Read this with me. How many players are there?
20.
So how long will it be? When you said 19, you're saying 19 for a reason. The reason is? Because, no, well, will it just be, because it's an array, will it only be 19 rows long?
No, because it's an array initialized using 0.
So when I ask you the question about how long it is, the answer is,
20.
but it starts at 0 and ends up as 19. Yes? Important to understand the difference. Yes? And that'll be something we'll need to think about, right? Because when we're saying we want to go for this first row, that actually be row 0, second row, row 1, etc., etc. Okay, let's get started. What's some things we're going to, if we want to collect and figure out the total score for each team, what's one of the variables we're going to need to initialize right at the start? First thing we'll put in place is a total red, total blue, and initialize to 0. Now, logically, we should always think through the idea before we write down the code. Let's think through what we're trying to do. We're going to have to go through each of these things. We want to go through each of here, and every time we see a 1, right, we want to do what with the value next to it. What do we want to do with that 45? Open up to the group. There you go. And every time where we see a 2, what do we want to do? There we go. So we want to step through this array, one after each other, get there. Now, one of the places where we might fall down is we know how to hopefully access a one-dimensional array, but it might be that you're not too sure how to access a two-dimensional array, right? And I can totally see how that could be the case. So this is just an array called, I don't know, stuff, which is a two-dimensional array. And what kind of brackets do we use for an array? I'm not asking you to write this down, I'm just doing this to demonstrate how it might work. If it was a one-dimensional array, we'd have like I in here or whatever, and that would indicate position 0, 1, 2 as we're going along, right, in some kind of an array here. So for instance, that would be position 0, position 1, position 2, position 3. But once we've got a two-dimensional array, it's actually going to go in this direction as well. And then you might be like, well, okay, how do I say this one versus this one versus this one? In this direction, we're saying rows. This direction, we're saying columns. And actually, what it comes down to, as long as we're consistent, then we can actually do it in either way, but as long as we're consistent. But let's talk about how we're going to do it, so that we're going to do it exactly like the exam board demonstrates. So we're going to have I and we're going to have J as our two ways of indexing it. Here will be 0, 0. Now that seems pretty obvious. Question is, what would that be? Is that 1, 0 or 0, 1? The way that they have asked you to do these ones is that the I would indicate the row number, and J then would refer to as the column. Yeah. So this is row 0, this is row 1, this is column 0, column 1, column 2, column 3. So for instance, here, what would be the values? Well, it would be row 0, so 0, comma 2. And here, what would it be? It would be comma 1. Here, yeah, okay, got it? Fantastic. Now, we want to step through this array. What we could do is we could write loads and loads and loads of statements where we increase it by 1 every single time, but instead of that, we will do for loop. Makes sense because we know how many different values they're going to be as we step through it. So we'll say for, and then we need something to count. That could be whatever. It could be C, it could be I. I'm very fond of the I. I equals 0, so it starts at position 0. Why does it start at position 0 again? Because, yeah, in an array, the first position would be 0, and therefore we're going up to what?
Scaled up to 19.
19. Now, some people, what you could do, alternatively, you could do player.length -1 potentially, but then be careful with .length in two-dimensional arrays because, of course, in a one-dimensional array, it's quite clear what the length is. In this, do you mean that way or do you mean that way? You see the issue, right? So in this case, we're going to say it's going to go up to 19. Brilliant. Okay, what are we going to do as we go along? What are we going to? So we start off at this position here. What are we checking for? So as we're going to step through this array, we need to check what's inside this column and if it's 1 or 2, and then use that to take this value and add it to our total of red and greens. So to do that, I say we go if. So if, and what's the name of the array? Player. If player, now can I do this?
No.
Why not? And that's saying like the entire array is equal to 1. Does that make any sense? No. Agreed. So instead of that, I have to sort of stipulate, don't I, which particular bit I'm doing. So I need to actually access the array. So what kind of brackets do I use?
Square bracket.
And then I need to access this one, and then this one, and then this one, and then this one, etc. as go down. Now, how do I do that? Got a suggestion. Let's try it out. 0, 0 would be that position. And then when I becomes 1, that will be 0, 0. And when I becomes 2, that will be, so you're going to check that position 20 times. Is that what you want to do? Right. So we're getting closer, but not quite where we want it to be. We want it to check that position, and then that position, and that position. How do we do that? So we've had a suggestion. It might be 0 and comma I. Let's see how that would work out. So the first one here is the row. So it's row 0. So it's going to be at row 0 and then I. So it's going to look at position 0 and 0. So it's going to see if that is 1 or 2. Then it's going to look if that is 1 or 2. And then it's going to look at that, and it's going to fall out of the array. Had another suggestion that it could be 1 comma I. 1 would indicate the row, so it's that row there. So it would be 1 and 0, so it would check that. Then it would check 1 and 1, it would check that, and then it would fall there, and it would fall out the array. After a heated discussion, we've come to the conclusion that maybe what we want to do is have the first one as being I, and then the second value for the column being 0. Now, if you remember, we said here is that the first value is row, and the second one is column. So I originally would be 0. That would be 0. So 0, 0 will be that position there. The row down will be row 1, Okay, and I will go up to 1. I'll be 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0. So we're going to pick that up. Okay, so I'm going to go around trying to solve this. We're looking now at this position as we're going down, and what we're going to be looking for is whether it's a 1 or a 2. If we say equals equals, so that's a comparison. If it's equals equals to 1, it means it's the green team. So what we're going to need to do then is we're going to say tot green. So the total from green is going to be equal to whatever the previous version of tot green is going to be, plus, oh, I'm pretty sure I'm getting right on space here, plus, what's the name of the array? Player. And then square brackets. We're going to go at position I, because if we found this one here, we're looking at position I, but now we're not looking at column 0, we're looking at column, bingo, column 1. Okay, so that's going to say total green, which is 0 originally, plus whatever the total green. I have to do that because otherwise I won't be storing the previous one. I'm going to rewrite it. So if I didn't include that bit there, I'll just be rewriting total green every single time. It's going to total up. What's next?
Else.
Do else. And then for else,
You can say tot red equals tot red plus player I and 1.
I, comma 1. There we go. So let me do that quick. I've used a slightly different technique here. Essentially, it's shrinking this tot equals tot green plus. If you go tot plus equals, that's the same as saying tot red equals tot red plus. So it's just making it a little bit more efficient that way. And then I'll do an end if. And then I'll do a next I, because it's going to increase I as it's going along. Once that's finished, am I done?
End.
Am I done? Am I finished?
You need print for schools.
You do. You do. So I'll do a print. I'm going to be a bit lazy. Well, not just lazy because I'm low at space, but you might want to do something. You could concatenate team red scored X, but I'm not going to do that. What do I put in this here box? Yeah, exactly. I don't think it says which way around it to be. Although, like I said, I think what you would be wise to do if you were doing this as real code, be like speech marks. The red team got speech marks plus tot red, because otherwise it's like a bit ambiguous. Beautiful. Previously, I've talked about how some of us don't take the time to read the questions properly and therefore aren't able to answer the question. It's a classic thing. We can make assumptions. What is required here is to take the time to really read through and understand the question before you go anywhere near implementing it. So what we've got here is a graph structure. Yes? What kind of a graph, by the way?
It's a weighted graph.
It's a weighted, unidirectional or bidirectional graph. Yeah, absolutely. It's not actually relevant to know that right now. I just like to plant seeds, right? And what it's doing is it's identifying on this data structure locations and then the overall cost to go from one place to another, the cost of a flight. A function called trip cost exists. What does it do? Well, it's been written that it takes in two cities, so Lisbon and Prague or whatever, and returns the price of a direct flight. So if I put in Lisbon and Prague, would it return a result for me? No, because there's no direct flight. It'd have to be Lisbon or Barcelona, Lisbon, Paris, Lisbon, Dublin. And in this example, trip cost, if I send it Dublin and I send it London, it returns 90. So you see you got Dublin, you got London, and that's the price of direct flight. Now, this is where we could easily go wrong. A journey is represented by an array called cities. So this one here. So this is not an individual trip. This is a journey of trips. An example of a trip from Dublin to Rome. So this person's going from Dublin to Rome. Now, can you go from Dublin to Rome directly? No, so it's making all the hops on the way to get there. So it's going to go from Dublin to London, and then London to Paris, and then finally Paris to Rome. So it's going to have to go doop, doop, doop. And the total cost is calculable by adding up all those individual ones, right? Because it says in here, write a program in the language or pseudocode of your choice that uses the city's arrays. Oh, what type of array is this, by the way? What type of array? One-dimensional array holding these strings, these names of these cities. of your choice that uses the cities arrays to calculate and output the cost of a given journey as a monetary value. In this case, the above would be £950. Now, if you've misunderstood what the nature of this array is, it's tried to give you a little bit of information here, the £950. Because it's going like, well, maybe you didn't quite get what we were asking, but you see Dublin to London's 90, London to Paris is 650, so that's 740, and then Paris to Rome is 210, so 740, 210, you do in your head is 950. It's giving you additional information so you can actually make sense of it. Okay, hey, guess what? The first thing we need to do is we're going to try and get the total cost. So very much like the last question, what's the first thing we're going to need to do? Initialize a variable to equal 0. Hey, guess what? That's actually worth a mark. Some of you will got a mark. We're literally writing down total cost equals 0. Boom. Let's be frank. If we have an array nearly all the time and we want to step through the array, what kind of a loop are we going to want to use? Absolutely, right? Because we know how long this loop goes on for. We need to step through this loop and then send it Dublin, London, and then London, Paris, and then Paris, Rome. That's what we need to send it. Correct? So in this case, what we're going to want to do is use a for loop. But I'm going to ask you, and let's see, we'll use I again. What position we start at?
0.
Yep. Now, this is where you need to think for a bit. What does it need to go up to? Okay, I think we should do this. I'm going to put in cities.length. And let's see. Okay, well, that might be somewhere. Okay, well, let me put that in. Cities.length -1. Because that's the name of the array. The array is, where do I not see it here? Cities. Cities. And I can totally see why you do that. It's actually wrong. Okay, but I think it's worth our while going through it and seeing what the problem with it is. Because it won't actually be clear at this point, and stuff like this could easily happen, right? Where you've not noticed something, so -1, and it'll become clear as you go through it. And it's totally fine. Yeah, but let's go through it and let's see why that's the case. So on the face of it, that makes sense, right? It starts at 0. What's the length of cities going to be? How many items are there in cities? 4. -1 would be 3, so it makes 0, 1, 2, 3. And on the face of it, that makes sense, right? We're going to go start at the beginning, we're going to go to the end. What do we need to do as we go through this? What do we need to do as we go through this array? What are we trying to do? What do we want to do? What do we want to do? What we're going to want to do is, as we step through the array, is we're going to want to take these string here and this string here, feed it into trip cost, so Dublin, London, and get the value, so £90. And then what do we want to do with that £90? We want to add it to total cost. So let's do this. So we got total cost. So total cost. And then we need to do equals total cost plus. But what was the thing I just talked about as a shorthand for that? Plus equals. And then what's the function we're sending it to? This function over here called trip cost. Yes? So we'll call trip cost. And then we need to send it. We need to send it that one and that one. So how do I do that? So what's that being held in? What's that being held in? Cities. Well, you're missing something out. You're close. What you're missing out? It's an array. It's special because it has square brackets. So square brackets and, as you were saying? Yeah. Whoa. Don't forget, say the square brackets. Otherwise, in the future, you might forget it. Yep. Then comma. Okay, guess what? That's going to work, isn't it? It's going to take cities at position. Oops, I think I just broke that again. It's going to take cities at position I, which will be Dublin, because I is 0. 0 plus 1 is going to be 1. It's going to give you Dublin and London. It's going to return 90. It's going to add that to total cost, and it's keep doing that. It's going to go around. Now, I said that there's a mistake here. Yeah, fantastic. So we've spotted the problem. The problem's going to be this. Currently, the way it's set up with this cities array of length 4, it will go from I0 to the length, which is 4, -1, so 3. Eventually, I will then become 3. And in here, it will say, look at cities at position I, which will be Rome, plus cities at I plus 1, which will be, and it'll fall array out of bounds, it will fall over. Anybody know what the fix for that's going to be? Yes. -2 is exactly right. So you don't go right to the end. You need to go one back from it so you don't end up falling off. The last I would be 2. So that would be Paris. And then 2 plus 1 would be Rome. Fixed. So the fix for this would be to actually make that -2. And that's making everybody happy. Am I finished? I probably have to output it, don't I? Or output the cost of a given journey. Right. Also, why didn't I just write down I equals 0 to 2? Why did I say cities.length? Yeah, totally. So this should be set up for any array you're sending it, called cities. It will fail, actually. If I set it an array of length 1, it will fall over and break, because obviously it will go from 0 to -1, which ain't going to work. But then having said that, can you calculate the duration of a length or journey with only one destination? No, that's not going to work, is it? Like, we can go where? You can go one place. Okay. What's the cost? It's free. And then I probably need to output it, so I just need to print. What am I going to print? Yeah, and as I said before, in fact, let me do it. I'll do the hard work now. This is serious hard work. The thing this time percent the total cost is, and then I'm going to add on what? Total cost. And then bingo, all good. So this question is one where you're not required to write your own code. So it's a piece of cake. All you got to do is follow it. No worries, right? Unfortunately, some of these questions are quite tricky and they can get you lost, especially since you've got lots of combinations of ifs and whiles and ifs and about exactly where you're going to end up. And also the use of the mod div function about exactly how they're going to work, right? To start us off, it's asking us about a flag is a local variable. So flag, where are you? Here we are. It's local. Hey, how do we know it's local without being told? Without being told that it's local, how could we assume it is local? It's been declared within the subroutine, the procedure of this kind. Of course, I suppose, admittedly, there could be a flag outside it, and therefore it would be global. So I suppose it does need to, because we can't see what the main bit of code is. Anyway, explain why str is needed in line 8. So here we are. So str, in this case, is short for string. So, and in this, do you remember what it's called? When str and you're putting things in bracket, it's called something beginning with C. It's when you change it, casting, yeah? When you cast from one data type to another, so you could cast from string to int, from int to string, etc. It's saying, why are we using it in this context? Well, you can see what's happening here. X mod 2, do you reckon X right there is a string, or do you reckon it's an integer, isn't it, right? Otherwise, can you do maths? Could you do, what's like, if you had a string and you did mod 2 to it, is that going to work? No. Right, so that is an integer. And then it's turned that into a string and then plussing something to it. When you plus something to a string, what happens? It's another thing beginning with C. When you get a string and you add concatenation, isn't it? It's going to. So that's the answer to the question here. If you didn't put the string there, x mod 2 plus y, and it was an integer, it would literally do an arithmetic addition, wouldn't it? It would just add the number to it. And that's clearly not what's intended. What's intended is to convert it into a string, and then when you add y, you concatenate to the string, and then you stick it on the end of it. Okay, that's where the answer comes from. But I wanted to focus on the actual subroutine itself rather than necessarily this question. So in here, we've got show the result of y. If you see here in this procedure, difference between a procedure and a function. So yeah, so this is a procedure, therefore it doesn't return a value, and in the end, actually what they do with the value, they just print it out. Yeah, and if it was a function, it probably would say return y, most likely. All right, show the result of y where the procedure is called fun1, well, it's called, so they call, and you call it with the value 10. The subroutine has been called, and it's been sent the value 10. Where does that come in here? So x, right? So this, what's that called, by the way? Beginning with P, parameter. Sometimes referred to as arguments, but we're trying to be consistent, call it a parameter. And so the parameter it's going to receive, it's going to be sent 10, and x will become 10. And in fact, with me, because you've not really been given a set thing, I'm going to say x, I'm going to create a little, why don't I create a little trace table? That would be fun. And so x will be what? 10. There we go. I probably haven't got enough space here. I'm going to regret this. And then it's going to say y equals what?
Y equals nothing at the moment. Just add the string.
Beautiful. Is x less than 0?
No.
So do we do this stuff here? No. So what line are we going to jump down to?
While.
While. Is x bigger than 0?
Yes.
Yes. So are we going to do line 8?
Yeah.
So x mod 10. So 10, x is 10 mod 2. 10 mod 2, what's that going to give you?
5.
10 mod 2 is going to give you 0. In fact, it's just saying essentially whether it's an even or a not even number, isn't it? Right? So in this case here, x mod 2 is going to give you 0 plus y at the end of it. So y was this, so it's saying it's going to have 0 and a y at the end. So it's going to give you 0 at the moment, isn't it really? Oh, what was I? I'll try and be consistent. I'll use red for y. So 0 and a string. This bit was stuck at the end, right? It's important to notice that, isn't it? It's not this plus 0. It's 0 plus that bit at the end, and it'll become relevant when we get more values. And then x equals x div 2, and 10 div 2 is going to give you
5.
yes. So 5. So if x is 5, we're going to go end while, we're going to come back up here, and now what? Yeah, it's 5 bigger than 0. Yeah? So 5 mod 2 is going to give you 1 plus y. Now this is where I'm relevant, okay? So is it going to be 0, 1 or 1, 0? See here? Yeah, and that would be very easy to get the wrong way around, wouldn't it? Really easy. So that is saying this, and then it's adding whatever y is at the end of it. So it's going to be 1 and then 0. And then x div 2, 5 div 2, sorry, I'm nervous asking you, but you're going to do it, right? 5 div 2. That'll teach me. Yeah. So, thank you, Sahin. It will be 2. So, what about now? Mo, what do you reckon? Do we carry on? Yeah, 2 is still bigger than 0. So 2 mod 2 is going to give you... What's that going to be? What's the new y going to be? So this is worth taking the time to think it through, isn't it? To make sure we're the right way around. You're right. But I'm put on Mo. No pressure. So that's y, 1, 0, which will be there. Yes. Okay. You see how easy it would be to, especially in an exam, how easy it would be to get the wrong way around, right? So it's always worth paying attention, because nearly always it would be y equals y plus something, right? So it's one of the rare occasions the other way around. So it's 0, 1, 0. There we go. I'm nervous to ask the question, Zaheen, but 2 div 2, what do you reckon? Should never be nervous. I wasn't nervous for a second. I don't know who said I was nervous. Crazy talk. Ashton. What is x currently? It is. So it's going to go, isn't it, right? So 1 mod 2, what do you reckon? 1 mod 2. It's whatever's left over. So how many 2's can you put into 1? So what's left over? 1, right? So that'll be 1 plus the y will... What's the number going to be here, do you reckon? 1, 0, 1, 0. Yeah, 1, 0, 1, 0. Because remember, we'll keep sticking up to this side here. I know I've mentioned it lots, but it's worth saying. X, 1 div 2. Zaheen, you're going to finish this off for us, and you're going to get it right. 1 divided by 2.
0.
Proud of you. Exactly right. Boom. And therefore, is 0 greater than 0? So therefore, this terminates, doesn't it?
Yeah.
So what line do we end up on?
It'll be print y.
Line 11 is what you said, right? Because we finished this while loop finishes, so therefore we're going to get to the line 11 now, right? Thank you for agreeing. Flag is equal to true. Is flag equal to true? Well, it says it initializes being false, doesn't it? And did it ever become false? No. So it's it ever become true rather? No. So it would still be false. So therefore y equals 0 plus y. So therefore y becomes 0, 1, 0, 1, 0. So I've not had the opportunity to look through this yet, so let's see if we can just blitz it. I'm going to do the same thing again by having a little trace table. Hopefully I have enough space for it with an x and a y. X starts off as what? Minus 13. So we can look at this one here. Y is a blank string. I'm not going to put anything down this time. We'll just say that's blank. Is x less than 0? It is. Therefore, flag. Oh, there we go. I've got an additional value to track there. Flag becomes true. What was the default for flag? False. X equals x times minus 1. So x will become, there you go. Unlucky for some. Is 13 bigger than 0? Yes. Most definitely is. So 13 mod 2 is going to give you 1. So y will become 1. 13 div 2 is going to give you
6.
And then 6 bigger than 0.
Yes.
Yep. X mod 2 is going to give you
0.
So y will become
1, 0, 1.
Unfortunately, you've just fallen down. Remember, this is the thing that I stressed about 1,000 times. It won't become 1, 0. Yeah. So in here, remember, you add it on the left-hand side because it's this plus y, not y plus this. Y becomes x, which is now x div 2. So 6 div 2 will give us 3. 3 bigger than 0, yes. 3 mod 2 is going to give you, so y will become 1, 0, 1. 3 div 2 is going to give you 1. I'm running out of space, damn. 1 bigger than 0, yes it is. 1 mod 2 is going to give you 1. And then y will become 1, 1, 0, 1. 1 div 2 is going to give you 0. 0 greater than 0. No, so we come here. Is flag equal to true? Yes, therefore... Yeah, right, there you go. Adds the front. There you go. So y will become... Yeah. 1, 1, 1, 0, 1. Alhamdulillah. So, on here, what does it mean? One of the questions was, what's actually happening? Can you see what it's trying to achieve now? Binary number in... A little bit more. You're there, but a little bit more. Boom. Yeah? Yeah. So giving... Oh, is it actually? It maybe it's sign magnitude, actually. Sign magnitude. Because, like, if you look at it, doing it in 2 is quite tricky, actually. Sign magnitude, do you remember the difference?
Yeah, use 1 to represent negative numbers.
Yeah, in that one, the last number in sign magnitude is basically like plus or minus. 0 will be plus, 1 will be minus. So that would be 8 plus 4, 12, plus 1, 13, and then the 1 at the end makes it negative 13. If it was in 2's complement, you'd have to have like... It'd be a lot trickier to calculate, actually, using this algorithm. So it's a sign magnitude version of negative numbers. So, Kano maps. So Kano maps, remember, the idea of this is just Boolean simplification. So you can either use that by Boolean algebra, or you can do that via a Kano map. So it's about simplifying a logical circuit. So essentially what we need to do is we need to fill out the grid by looking at these these logical statements. So A, what does that symbol mean? We've got that one, we've got that one, we've got that one. The upside down V, that would be a... The upside down V would be a... And. The V that way around will be an or, and then that's a not. Remember, one of the ways to try to remember that is that that one, it looks a bit like a V. Imagine that it's versus this. So this or this. I don't know if that's helpful. That one looks like an A a little bit. That could be an and, maybe. And that one, that is truly awful. Even for me, that is poor drawing. 1 second. Let me try and make that slightly less terrible. Boom, there you go, that's a not. All right, what we have to do here is we have to populate this KMap with these. So where A and B are what value? Where they're 1, so it's where they're true. So we need to see where A and B are true, where they're 1. So that's true here and here. So guess what, down here, what you have to write down? 1s. So that'd be 1, 1, 1, 1. And then on this one, not A, so where it's not A, so that's where it's 0, and B, so that one here. So all the way down here, you see that? Sweet. Oh, I could do a different color coding. Now, let's keep it simple. 1, 2, 3, 4. And then finally, or where it's not C, so that's where it's 0, and not D, so it's going to be here. Not C and D. Rules of KMaps is that we want to draw boxes as large as we can and as few as we can, and we can totally overlap. So the first obvious and big box, and boxes have to be 1, 2s, 4s, 8s, or 16s. First big box we can do, and they have to be regular shaped, they can't be misshapen. So that's one right there, so that's a nice big box for us. That's one, and the other one, that's pretty obvious, is this one here, right? And we can totally overlap, and that is fine. Cool? And then we have to identify for this red one here, what does that symbolize? And the way you figure that out is you look at what changes and what stays the same. So does C, does that stay always as 0 or always as 1? Well, sometimes it's 1, sometimes it's 0, so it can't be that. What about D? Sometimes it's 0, sometimes it can't be that. Okay, fine. With A, sometimes it's 0, sometimes it's 1, so it can't be that. But B, it's 1 here and 1 here. So it's always B, so this represents B. So that would be B, and then you combine that with or, and then or whatever's in this blue box. Same game again. We have to look at what stays the same and what changes. A, is A always 0? No, it could be 0 here, or it could be 1. What about B? It could be 0, it could be 1, so it's nothing to do with A and B. What does stay the same? Not C, so it's always not C. But also, what about D? It's always not D as well, right? So we open another bracket, so we can say not C, and what do I combine it with? And not D. Okay, so for this question here, I don't think I'm necessarily going to rock through all the individual questions. And it was this one here where a lot of people got the answer actually wrong as to why 2's complement might be preferable to sign magnitude. Now, what a lot of people said is that like it allows you to store more numbers, an additional bit or something, but ultimately it can allow you to store like one more number because essentially you don't have to have positive and negative 0. But that's not the main and real. What's the main advantage 2's complement is going to give you? No, it allows you to do arithmetic functions like subtraction. Can't you? If you think about it, that way you can add, if you have positive 14 and then you've got negative 7, then you can do plus 14 plus negative 7. Because you're storing that in negative, it allows you to do, I'll give you the mark scheme so you can check it out, but that's the thing you need to say. 2's complement allows you to do arithmetic like subtraction, right? That's the point you need to make, and yeah, it allows you to store one more value, but that's not going to be that important, like literally one additional value. Let's say you've got a 16-bit number. The difference between 16-bit number in sign magnitude and a 16-bit number in 2's complement is that one will store 65,536 and one will store 65,535. I mean, but the big deal is that if you've got inside magnitude, can you use that to subtract? No. But in 2's complement, you can do subtraction and addition with it. Overall, this one went kind of okay. Typically, people got the mark for making 47. They got the mark for making 23. Then they typically got the mark for making 23 in 2's complement. But some people then lost the last mark because they didn't actually add it up correctly. But I think that's just practice more than necessarily not being able to do it. But this one down here, using floating point and then using it to add numbers together, that's somewhere where we do fall over sometimes. So why don't I just bigger it like this? There you go, beautiful. And then we're going to do these questions. Basically, we need to add these two numbers together. I'm going to take a step back for 1 second and say 10.4 times 10 to the 3 and 1.2 times 10 to the 2, no, 10 to the 4, let's say. How would you add these up? If you want to add those two together, what would you do? So one of the solutions to do, and probably the easiest solution, is just to be like, 10.4 to the power 3, so I need to move the decimal point 3 times to the right. So it'd be 10 times 2, 10 to the 3 is times by 1,000. No, 10,000. And then doing that 1.2 times 10 to the 4, and then you calculate what the final thing is, and then you add them together. You could also put them under the same powers. You can make that 10 to the 3, so it could be like 12 times 10 to the 3. But either way, you've got to standardize it. It's the same here, right? So essentially, if I just rub these out for a second, because you see the logic there, it's the same logic here, except this time it's in binary. So you've actually got 0, 1, 1, 0 times 2 to the power 0, 0, 1, 0, and the other one is 0, 1, 0, 0 times 2 to the power 0, 0, 1, 1. Right? You see that figure there is this figure here, right? What can we do? Well, I think the obvious thing to do is to actually put that into fixed point by moving these back into whatever the fixed point version is for both of them. So for the first one, it's 0, 1, 1, 0. Where is the point going to be on that, being as that it's been normalized? Where would it be? So on here, where is the fixed point? Where's the point? Sorry, the floating point. Where is it always, if you've done it properly?
0.0.
It'd be either 0.1 or 1.0. 0.0 something, 1.0 something. So where is it here? Always between
0 and 1.
Always between the first two. So the point is here. And then the exponent is 0, 0, 1, 0. What number is that? 2. So we have to move this point. So we want to come that down to 0. So if we want to make the exponent smaller, what has to happen to the mantissa? If the exponent becomes smaller, the mantissa must become larger. Does the mantissa become larger by moving to the right or moving to the left?
Right.
There you go. And how many times are you going to move to the right? Twice. 1, 2. So then our number becomes 1, 1.0. So that's number 1, isn't it? That's our first value in fixed point now. Let's do the same thing over here. 0, 1, 0, 0. Where's the point? Between the first two. What am I going to do different with this one? Going to move the exponent right 3 times. Why 3 times? Well, this time because the exponent was 3. And therefore I can write down underneath it what it would be. It would be 1, 0, 0, dot 0. I need to add them up. Oh, what makes this simpler is, are either of them negative? No, they're both positive. If they were negative, it would be a little bit trickier. Indeed, we would. And we have to make sure we don't lose the 2's complement. But let's take these two values then. So we've got 0, 1, 1, 1. Oh, in fact, I've skipped a step there. So we've got 1, 1.0, and we've got 1, 0, 0.0. It's always worth making these similar to each other, so I pad that with a 0 there, and then I need to add these two together. When we add things together in binary arithmetic, any kind of arithmetic, do we start from the right or do we start from the left? If you can't remember, 32 plus 79, do I add from this column first or this column first? Oh, wow, yeah. I start from the right, don't I? I add these together, don't I? And then I add these. So I start from the right. So 0 and 0 is going to be 0, 0 and 1 is going to be 1, 0 and 1 is going to be 1, and then 1. 1, 1.0, is that the answer? No, because it's not normalized. Therefore, I need to move it once, twice, 3 times over here to make 0.1110. I moved it 3 times to the right, so the exponent would be 3. So it would be 0, 0, 1, 1. Is that in 4-bit mantissa? No. What am I missing? Or what do I have? I've got 5 bits, so which bit do I remove? The last one. So the answer would be 0, 1, 1, 1, 0, 0, 1, 1.